Next, it's my great pleasure to introduce Dr. Thornton from Battelle. Dr. Thornton is Technical Director of National Security Research and Development Program at Battelle, and he has many patents, over 40, and most recently, he won the close to $40 million grants from NTIA. Without further ado, Dr. Thornton.
Hi, so Doug Thornton. I've spent 17 years here doing undergrad, graduate school, and PhD. So I thought I was done with Ohio State, but then they made me come back to give this presentation. I didn't go far, just across the street. So like you said, I'm with Battelle, Technical Director, National Security. Right now, the business that I'm in is called Defense Material Solution, but I used to be in a group called Cyber Innovation, Cyber Solutions. I don't know what we call it now, Tom. Cyber something, whatever. So I have a unique perspective of, I spent about 15 years doing cyber physical systems work, understanding how those things go together and their vulnerabilities and all that sort of stuff. And then I moved over to actually producing the things that create vulnerabilities that people take advantage of. So now I have a dual exposure of what an attacker looks for, how do they analyze a system, but then go to the other side of, okay, why are those vulnerabilities there to begin with? And maybe how can we close the gap on bringing this together? So RavenStar is just a trade name for a compact phased array we have, and we've got a little Angry Bird logo that I always like to use because it's fun. So 5G network architecture. So if you're not familiar with 5G architecture, there's this dream of here's what a 5G system looks like. This is all nice, neat, orderly. Easy to secure. You can look at all these interfaces and say, this is what 5G is, and we're going to make everything better, solve all these vulnerabilities, but also make it efficient, make it virtualizable, be able to become vendor agnostic, so we're not so stovepiped and always paying ransoms to hardware providers and such. But then when you really look at it, this little box right here explodes into this little box right here, and these boxes are made of sub boxes, by the way. And then you have all these interfaces. So as a security researcher, every one of those interfaces is something you have to secure. You have to have a threat model for that particular interface and how they're going to work. So really quickly, this dream architecture that's really nice and convenient explodes into these very, very complex architectures. And that's just the dream of how a 5G system would work. What the reality is they have a whole lot of backwards compatibility issues. So your 5G system now, if you're on T-Mobile, Verizon, AT&T, it's called 5G non-standalone. That means your phone is saying it's 5G, it's doing some 5G stuff, but it's really going to a 4G core. So it's not even a full 5G system yet. So you have to have a LTE or a 4G tower next to a 5G tower for this whole thing to work together. So you're already enforcing backwards compatibility. There are other regions of the world where 3G still exists, and there is a legal reason those have to exist, that they have signed agreements with their government that this 3G tower will be running and you'll have a network until like 2035 or something like that. So 3G is still out there for cost effectiveness reasons. A lot of the third world countries will have possibly 2G and 3G systems running as their system today. So these are all interworking. Now let's add in roaming conditions. So now you have backwards compatibility, but then you have cross compatibility. So AT&T phones need to talk to Verizon phones and vice versa. And if there's no AT&T tower, there's a thing called roaming where you might be on a T-Mobile tower. So anybody who knows about tower deployments, the concept of an AT&T tower not being there and a T-Mobile tower being there is kind of strange, but yeah, that's the example I just came up with. So it's a very complex system, and complexity only really works if it's layered in over time. If you start with a complex design, you're never going to get it right. But this has been layered in over 40 years, and every time they go through and try to make it less complex, some of those needs and decisions come back, but also the need to be backwards compatible ties those secure new systems in with the insecure older systems. So what does 5G security really look like right now? So they did the proper thing. So if you go to the 3GPP standards, I'll add way too many P's at some point when I talk, but so look at 3GPP. You can go to their website. They have an FTP server for anybody who loves FTP servers, if you want to go back in time. they have this 33 series, which is all their security stuff. So like any good security research, you're going to start with your threat model. What is your threat model? So this entire complex network, we've defined it in 105 pages. However, there's a whole lot of boilerplate in there. There's really not a lot of content in that 105 pages, but they're trying. And they don't really go through a large number of the threats. They go through your availability, your confidentiality, all of your typical, let's go through the textbook and walk through. But not really like, okay, how can somebody exploit this system? How is somebody going to make money off of my system? And they got to think that way. So the next thing you pay attention to is a 300-page document for the security of the entire network. So you have a whole network that looks like this, and you're going to find the security architecture in 300 pages of, again, mostly boilerplate stuff. So then, yeah, okay, move on to, okay, here's the requirements, 112 pages, that's for everything. And then now the part that Battelle is working on is called the RU. So it's that radio to data interface. So you guys want data, I can give you 100 gigabits per second of data. Don't know what you want to do with it or how you store it, but that's what we can do. So for our security assurance specification, according to this standards body, that is a 24-page document telling me how to secure my radio. For me, is to simply test the radio and tell somebody that it works, I got to pass 450 pages. So that's just the state of the security. Now, there are, at least it's there. The security exists. They're talking about it, a lot to build from. And then you have these Open RAN working groups. So one of the goals in moving to a system like this is to decompose the little parts so you can buy the best of the breed. So you can buy innovation in one of those areas. A small business can come in and make an impact. Because when Ericsson or Huawei own that whole pipe, nobody's going to be able to get in and invade, and you're going to be locked in and relatively stagnant. So what this Open RAN group is doing is defining those boundaries in a way that are open and everybody can interoperate together, how you test together, but they're also starting through this, what's called Working Group 4, looking at security. So they're getting better at understanding the security of the systems and how to test and having requirements there. But that's only these interfaces here. There's other stuff going on there because the whole radio access network is this stuff. You've got the core network. I'm making this thing jump around, all in there. So some of the challenges. So like I said before, you got to support older technology. Older technology is going to have exposed vulnerabilities that can't be remediated because everything will break. So you still have to support those. So how do you have something known and vulnerable, bring it into the system and still have everything work? So then you've got your complex architectures, 5G standalone, non-standalone, all of these things going along. And then you're bringing them together. Complexity breeds vulnerability. And then you just have various different data types. So back when I was in college, you would still pay like 25 cents a text message. At least we had text messages back then. Now that would be laughable for somebody to be like, hey, I'm paying money per text message. So that's because that all went through different data channels and they could bill you differently. Those things all still exist. So there are different data channels, and moving voice from one type of data channel to another has been a big development in the recent systems. So you have multiple different data types. You have paging that's going to broadcast to everywhere. You have encrypted one-way traffic, all that sort of stuff in there. And then you've got these fun ones where, oh, if I don't have a SIM card in my phone, I still need to call 911. So now you have unauthenticated users being able to get on and make calls on your network, and that has to be supported. So combine that with networks that are traditionally supplied by a vertically integrated single vendor that goes from the radio all the way through the core, you get into a system ripe for security vulnerabilities, which if anybody follows the news, there was I think it was a very similar network switch or router vulnerability that got exploited and leaked a whole bunch of data, I think before November timeframe. So just to give you a sense of how these requirements are written. So if you are going to store your keys in clear text, so everybody knows you should store your keys in clear text, right? It makes the hackers faster. So store your keys in clear text, but you have to put it in a secure environment. Is eBay a secure environment? what happens when your servers are end of life? With your clear text data, you're probably going to recover some money. You're going to sell it to company A, company B sells it to B, C, and D, and then it's going to end up on eBay. And if I can find a server that has a 100 gigabit per second NIC that supports something like SyncE, something telecom specific, you're probably going to know that that was in a telecom rack. Buy it for $50, see if there's anything fun on there. So actual requirements that are coming from 3GPP, they don't really understand the entirety of their threat model, which includes eBay. So Battelle, we are a nonprofit charitable trust operating over 100 years now. We do about $11 billion of business a year as a charitable trust. Mostly that's through running national laboratories, kind of a management structure. And then we have our own, we would call it an equivalent to a national laboratory type thing where we have to go out and feed ourselves, find work, sell programs. But most of that is services work. So one of the questions is, why is Battelle doing a 5G thing, especially with hardware? And I'm going to explain that. So we came up with a way of packing antennas really, really close together. So this is all hardware physics, the type of thing Battelle does. When you normally put antennas close together, they get mad at each other. They don't work well. So you have to do a lot of RF modeling to get them right, and then you can get that right at a particular frequency. So what we figured out was a way to put a lot of antennas together, which is what you need for 5G and 6G systems. Get that high packing density, but the antennas are happy next to each other. They actually work together as friends. So we had that innovation, and we started to think, how do we go and turn this into some usable product? And then that eventually got us to 5G and what's called a radio unit. So anybody who's doing 5G research, typically you hook up into a software-defined radio that you hook up to a spectrum analyzer and a signal generator, and you never actually radiate out into the real world. Because radiating out in the real world is hard. You get into FCC, there's a lot of compliance issues, challenges with that. So what we've done is said, hey, okay, this thing's kind of like a software-defined radio, except it goes all the way out the spectrum. So we started looking at all these markets and getting a lot of strong market pool, including like $40 million of government money, in addition to other stuff where we're just taking this whole thing to market and going for it. So we stumbled upon a product, and that's where we're working. So I got roped from my cyber duties, analyzing and studying systems, to now building a system that should be deployed commercially in mass at tens to hundreds of thousands of units. So I'm now going to be providing vulnerabilities to other security researchers to entertain themselves. So yeah, what we're doing can change frequencies, functional flexibility. So anytime you have flexibility, that also can introduce vulnerabilities because that's more surface area you're creating for an attacker. So we're functional flexibilities, but what we want to be is this radio unit. And when you go back to an architecture like this, we are this little tiny box right here. And the government is investing hundreds of millions of dollars into getting people to make little boxes here in the United States. And then there's like all these other things. So just that little part of the network to give you an understanding of the complexity and the scale of these networks. So we're making those. And then one of the things we can do is we can bring the cybersecurity, that sort of stuff to the mix, but it's kind of funny. Everybody asks us the price, but they don't ask us what security requirements we meet. So that brings us to why the world is the way it is and maybe how we can close the gap there. So we always have cost and schedule pressure. So if anybody tells you the price of a part of a radio access network, they're wrong. It's because we have had prices all over the map. It's impossible to figure out how much something should cost. At a research, if I'm buying one or two for a research organization, those are known, but nobody really knows how much T-Mobile or Verizon is paying for a radio because they don't buy them one at a time. They buy 100,000 at a time, and it all gets diluted in complex cost systems. So that means everybody's working towards schedules and costs that are just really, really difficult to achieve. So security, unfortunately, is one of those things that it's not a value driver. So until a customer comes to you saying, I need a good secure system, and if the RF performance kind of stinks, I'm fine with that. Nobody's saying that now, but if they keep having vulnerabilities, they eventually will. So we have that same house of cards, even in the radio unit, that little part that touches physical spectrum. There's this house of cards of software provenance. So you're pulling things from GitHub, you're pulling things from third-party IPs. So you're even paying people money for third-party IP, third-party software to bring in them. You don't know the provenance of how many other people they've paid. It's this big giant, like a Jenga tower of different softwares. And then like you can get into one of those PIP situations where the one guy, one of the maintainers is like, I don't want this anymore, I'm removing it. And like the entire internet collapses because one guy got sick of it. So we can't really tell a full provenance of all our software. We know where we got it from. We don't have that second order effect of where they got that from and how that builds. So even though I'm building just a radio part, so to describe what's inside of the radio, you've got your antennas, you got all of your analog electronics, then you get to digital electronics, and then that digital electronics gets into an FPGA or an ASIC. But that's also got a coprocessor, which is going to run typically ARM processors. Somebody's getting into RISC-V now, which is pretty cool. But ARM processors running Linux, running real-time Linux, connected to Fabric. But then you have to control all these other things out. So then you end up with communication buses back into the radio with other things. So like there's little processors here and there scattered all up. So I've got stacks and stacks of software in this radio, including Linux operating systems where we're pulling in open source software to run some of our network stack. So the radio itself, even though it's got 100 gigabit fiber coming out the back, it's got an SSH shell and you can get in there. The password is definitely not RavenStar. That might be the username. These systems, they're inherently, because they're complex, they're fragile to begin with. So just getting a 100 gigabit connection to work in the first place is hard. Now let's put a couple kilometers of fiber. So the speed of light is actually kind of slow when you start working systems like these and you have to get them synchronized and all that. So this makes the system inherently fragile. And we're just desperately trying to get the darn thing to work. And you're going to be like, oh, I'm going to add 45 nanoseconds of latency to run this AES accelerator on your data. You're like, no, that's like 5 miles, people. So yeah, it gets pretty crazy. And then there's always the self-confidence of industries that are normally stovepiped, where you're looking at yourself, you're inspecting yourself, you're not giving it to a third party. You maybe hired somebody who interned at the NSA for a quarter, and now that's your security expert, and they're being their own lawyers. Like everybody knows, you don't want to go and be your own lawyer in a trial. That's what people are still doing with security. Like to say that we are trying to fix that with our NTIA grant. We're actually paying somebody else to review our security and pen test our system in a way, according to the process, not to complete freedom, because that would take a lot of effort and they'd find stuff. But assumption, advocacy, sophistication, motives. So I had early in the career, we had a effort in commercial vehicle security where we brought in commercial people and showed them some of the tools hackers are using to understand their systems. We showed the tools. We showed, at that time, integrated disassembler. You guys live in a world where Geeger's free, so yay to that. But they had IDA. We showed this guy IDA the first time. He was in charge of security at some company. He came back the next day and he said, last night I cried. I threw my code in to that tool you showed me and everything was there. I was like, I already knew that. That's why you're here. So oftentimes you don't know the sophistication an attacker is going to bring to the table where, oh, your block cipher, I know what a typical AES block looks like. So I can find that. Now I can find your other functions. I can find those functions where you're using it. And now I can trace my way all the way through. They just don't understand the mindset. So that's always a technical challenge. And that shows up in that first part where you're looking at what is my threat model. If you don't understand what an attacker is going to do and how they're going to threaten you, you're not going to be able to create a threat model. You have to have actual attackers do that. So other operational challenges. So this is physical infrastructure. It's like your router, but a very, very complex router that's spread all over the world and made up of different components by different vendors, and you have really no clue what's going on. So my Wi-Fi router at home, I run a Ubiquiti network, so I won't give you my address, but you'll probably war drive it now. But so certificate management. I can't even sign to a Ubiquity network, which is like a prosumer type thing, because the certificates expired. Like just getting new certificates onto those cyber physical devices, those embedded devices is hard. So just all that certificate management becomes an issue. How do we do this? Because people don't want their stuff to go to the field and fail because they can't log in. So I can give you a very specific example. We just sent one of our radio units out to Colorado for a third party to test. And you have all of this open RAN, like here's the password, here's the security, here's this thing called the in-plane, and this is how you log in, and here's a certificate and how you do the exchange and all that sort of stuff. And they say, can you just give us an SSH password to get in this thing? Like, yeah, of course, it's not RavenStar, it's something like RavenStar 2. But so yeah, you now are just handing plain text passwords over email, all this security build up, but just the practicality of I've got time constraints, I got to go do this test. Can you just give me an easy way in? And of course, yeah, we have SSH open so anybody can get in, not even doing the certificate-based thing. So yeah, there's just this whole usability thing that really drives security lower. And what you often find is in systems like these and other complex systems is those tools put in for developers to do their work that are going to be removed by the time you ship the product don't get removed by the time you ship the product because they ran out of time. That was the last thing on their to-do list, and their to-do list keeps getting cut. So you've got thousands of radios all over the place. The last thing you want to do is, oh, I lost their certificate. We're going to have to go out and manually reset all of those. It costs more money to drive out and go access that radio than what that radio costs. So if you're going to drive out there, you might as well change the radio too. And then you have this desire of the data, like you've heard everything already with the previous presenter, like data is everything. So if I'm putting a radio out there, I want to get some data on how it's doing. I want to make my radio better. So now I need a way to get in. And maybe I want to sell you additional software features that I will unlock. Or maybe worse, I'm going to license the software on that radio and it's going to expire in 12 months if you don't pay. So now I need a direct access in. So now you don't even have control of something on your own network. It's getting accessed from a third party. So how can we go forward? So I got cyber experts over here, what they can do, industry experts, and feedback. So I did control theory. So how I ended up in this world, I don't know. But I like feedback loops. So what is a realistic adversary-informed threat model? So any industry, this could be useful. What is a realistic, not like toys that I'm going to go share at one of the big hacker conventions, but like something actually that's going to cost money, do that sort of stuff. What are those? What are the objectives? Why might they do it? Usually it's money. Sometimes it's pride, fame. Usually it's money. And then what are the other cyber physical systems doing? How do we get those over there? Share those with the industry experts. They need to broaden those threat models. Make things less qualitative, because that's one of the challenges. That's when costs explode. Because a qualitative response, Battelle would be happy to charge 40 engineers for 6 years to analyze your system. It's an unbounded problem. You have to bound the problem, and that means quantitative. Start doing testing third parties, so don't test your own stuff. And then you got to up security to be a first-class requirement. It can't be these little things. So, but also they need to tell security research what does the real world look like? Not this fancy world that we want it to be, but what does the real world look like? How are we actually trying to put things together? So like, okay, maybe SSH with a fixed password isn't a good idea, but we can come up with something easier than this whole key management problem, maybe. And then disaggregation and transparency, all of that go together. And then how do we innovate on the primitives? Bring those up. Start with well-known good primitives, bring those up. And then have a little bit of sympathy for these people. It kind of sucks to be over there. But then also get, how do we bound the security research? So do it in a fixed period of time. And that's all I got. When I was developing the talk, I could have quoted you the standards I need to meet for radio performance, but I had to look up the numbers of the standards for the security performance. So why is that? Because I will go to a conference, I will be talking to people like, where are you at with your 141-2 compliance? Like, oh, da, 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 da. Nobody's asked, were you the 33.156? I don't even know the number, obviously. Like, where are you at on those? Like, nobody asks. So it's not on the top of my mind. So it's going to really have to be customer driven. So what is a customer? What are they asking for? When they start asking for security, people are going to start giving them security. And that's ultimately what's it.
All right. So let's thank Dr. Thorson one more time.